Now after the direct method where we have calculated the mean of the grouped data, let us suppose if there exists a situation at a particular point in which the product of fi xi is very tedious and we are not able to find out fi xi in an easy manner. So for that cases, when the calculations are very lengthy and tedious, we have to move on further towards the second type of method, which is nothing but called as the assumed mean method. So in that cases, we opt the assumed mean method. So let's just see what is actually an assumed mean method. So in the assumed mean method, we always select a particular kind of a representative. What does it mean? We choose one among the xi's as the assumed mean and we denote it as nothing but a small a. So that's why by the name it is assumed mean method. We are actually assuming a particular element a over here which is among the xi's and we call it as nothing but the assumed mean. And further, the second step would be like, or we can say a note would be like, take a to be that xi which lies in the center of x1, x2 and so goes on xn. So always remember, whenever we just are selecting our assumed mean, that is a, so it should be among the xi's and it should lie in the center of x1, x2, x3 and so goes on. So let us suppose if I'm just taking the previous example that I have taken for the direct method, let us suppose this was the example that I did in the direct method. So here let us suppose if I just have to select what should be my assumed mean. So as you can see over here, the element that we have to select means the assumed mean that we have to select should be among these xi's, and it should be in the center of, x1, x2 and so goes on xn. So let us suppose if I'm just taking the center of the x1, x2 and up till so goes on xn. So you can see the center is actually these two elements. So you can opt for any of these particular elements, but here I am just taking this particular point because its frequency is greater. So I am selecting this one because of the reason that its frequency is greater. So here I am assuming the assumed mean, that is nothing but a, as is equal to 47.5. So you can opt for any a as 47.5 or either you can opt a as nothing but 62.5. but whenever we have such kind of a situation in which we have the two values and we have to opt for any one, so always go for the element or for the class mark or for the number which do have a greater frequency. So among these two we have the greater frequency with this only, so that's why I'm assuming 47.5 over here. So let us suppose if I'm just assuming my assumed mean a as 47.5. So let's just move on further and see what we can further do for the further steps to find out the assumed mean of this particular given data. Now after selecting the assumed mean, that is nothing but the a value, so the next step would be like find the difference di between a and each of xi's, that is nothing but called as the deviation of a from each xi. So the deviation is represented by di, so we have the deviation di as nothing but the difference of every xi from a. So the difference in between these two is nothing but called as the deviation of a from each xi. So the next step would be like we have to calculate di, means we have to form a table of di which is xi minus of a in the assumed mean method, and the next table that we will form should be nothing but a table of the product of di deviation with respect to the frequencies. So the next table should be of the form find the product of di with the corresponding fi and take the sum of all fi di. So let us suppose if I'm just taking an example of the previous question that we did for the direct method. So let's just suppose I'm taking the same table, means the two tables that have the class intervals and the class intervals and the frequencies, means the number of the student that do have the marks over there. So let us suppose if I'm just taking that question again. So first of all, just neglect these three tables. First of all, I'm just talking about this information only that we already have have in the previous question. So we have the class intervals as this, we have the number of the students which are represented as Fi as nothing but this. So we have this particular table. So as per the assumed mean method, we have to form the next table, which is nothing but a table of class mark, So this is the table of my class mark. We already know how we can find the class mark. This is upper limit plus lower limit divided by 2. So this is 17.5, 32.5, 47.5, 62.5, 77.5, 92.5. And now we have to take the sum of all the frequencies, which is representing sigma Fi, which is nothing but is equal to 30. So this is the same table that we already have done in the direct method, but there is a change in the next table. Now we will not find Fi Xi because that task would be tedious. Now we will find the next table as nothing but Di. So what is Di? Di is nothing but the deviation, which is actually a difference of Xi minus of A. So let us suppose if I am writing it over here, Di was actually nothing but Xi minus of A. What was A? A was actually the assumed mean, and let us suppose if I am having or I am selecting the assumed mean from all of these class marks. So we already have selected our assumed mean as 47.5. So you can select any among 47.5 and 62.5, but I am selecting 47.5 because its frequency is much more greater than that of 62.5. So this is my assumed mean that I am selecting. Let us suppose if I am just taking it as nothing but A. So it means that I'm actually subtracting each xi with the A is nothing but 47.5. So this is a 47.5. So let's just start finding out the difference of xi minus 47.5. So let us suppose if I'm just starting with the very first xi, this is a 17.5. So I am just calculating the very first D1 deviation. D1 deviation is nothing but x1 minus 47.5, which is x1. You can see x1 over here. X1 is nothing but 17.5. X1 is nothing but 17.5. So let's just calculate this one. So we have this as 17.5 minus of 47.5, and definitely you can see the answer is coming out to be equal to minus 30. So this is my very first deviation, that is nothing but D1. You can see all by yourself, this is my very first deviation, D1. Now let's just find D2. D2 is nothing but is equal to x2 minus 47.5. x2 is nothing but 32.5. This is 32.5. Let's just plug in the value over here, 32.5 minus of 47.5. This is nothing but is equal to minus of 15. Now you can see all by yourself that this is nothing but your D2. And in the similar way, we can find D3, we can find D4, we can find D5, and we can find D6. Now this is the table of all the deviations of the A assumed mean. Now let's just calculate the next table, which represents the product of Fi with Di, means the product of their deviations with respect to their frequencies. So as you can see, we have the frequency as nothing but 2, the deviation is nothing but minus of 30, so their product is nothing but minus of 60. Now let us suppose if I'll write it over here, we are taking the product of 2 with respect to, this is nothing but 2 into minus of 30. This is actually representing 3 into minus of 15. This is nothing but 7 into 0. This is nothing but 6 into 15. This is nothing but is equal to 6 into 30, and this is nothing but is equal to 6 into 45. And if I just take the sum of all these, that is sigma Fi Di, this is nothing but coming out to be equal to 435. So sigma Fi Di is nothing but 435. Now here we will use special kind of formulas, that are the formulas for the assumed mean method to find out the mean. So the very first formula that we are going to use over here is nothing but called as the mean of the deviations Di. So the mean of the deviation Di formula is actually nothing but D bar, which is equal to sigma Fi Di divided by sigma Fi. So how we can find the mean? Let us suppose if I'll write the formula over here, the formula that is nothing but the mean of the data over here should be is equal to a plus of sigma Fi Di divided by sigma of fi. So this is actually which is nothing but the mean of the data, and we can also write it as nothing but a plus of d bar, because we know that d bar is actually representing sigma of fi di divided by sigma of fi. So the mean of the data using the assumed mean method can be calculated as A is representing the assumed mean, we definitely know that, plus sigma fi di by sigma fi, which is representing d bar. So using this formula, now I am going to find out the mean of this particular data. So let's just find it out. We are starting with the mean. So the mean is nothing but is equal to a plus sigma fi di divided by sigma fi. So let's just plug in all the values over here. We already know about all the values that we have. So first of all, we can see we have a as nothing but 47.5. We have taken a as 47.5 plus of sigma fi di. Sigma fi di is nothing but 435. So this is 435 divided by sigma fi. We know about the value of sigma fi, which is nothing but 30. So this is nothing but 30. So let's just calculate this value first. When you will cancel all these values, you will get the answer as nothing but 14.5. So at the end, we are getting 47.5 plus of 14.5 means we are getting the answer as nothing but 62. So hence at the end, we are getting the mean of the same data that we have already calculated using the direct method, that was actually coming as is equal to 62. We are getting the same answer, the mean of this data again as 62 using the assumed mean method. So this is all about the assumed mean method. Always remember, in the assumed mean method, we will start with the assuming or finding out the assumed mean first. So that would be our step number 1. And the second, we have to find the deviations. And the third, we have to find the product of the frequencies with the deviation, and then we have to calculate the mean using the formula mean is equal to a plus sigma fi di divided by sigma fi. So this is all about the assumed mean method.